Hello, welcome to this video. Here we are going to learn recursive functions. Recursive function, a function that calls itself directly or indirectly to solve problems is called recursive function. Basically, this technique is used to break down a complex problem into smaller, more manageable subproblems of same type. When recursive function call itself, the memory for call function allocated and a different copy of local variable is created for each function call. Commonly, recursive functions are used to solve these problems such as finding factorial of a number, finding Fibonacci series, solving Tower of Hanoi problem. Key components of recursive function. Base case. This is a crucial condition that defines when recursion should stop. Without base case, function would go itself indefinitely, leading to a stack overflow. Base case typically provides a direct solution for smallest or simplest form of that problem. And another is recursive case. This is the part of the function where it calls itself with modified or smaller input, moving closer to the base case. Structure of a recursive function. Now, syntactically, it is given that return data type and the function name, and it has parameter list. Most of the time, recursive function has parameter and return data type are compulsory. Now, in the body of recursive function, if you see, there are two parts: base condition and recursive condition. Base condition is always given, base case is given in if part. If and the base condition is checked using a variable or conditional variable. If base condition is satisfied, that is, base condition is the simplest form of problem. If it is satisfied, it return a basic value of that problem. If not satisfied, it will go to the else part, that is the recursive case, where function is going to call itself. So it is written within the in else part, the function calls itself with return keyword, function name, and the updated variable or parameter. Let's see recursion example for finding factorial of a number. Factorial of a integer n is product of n into n minus 1 into n minus 2. So same thing recursively can be given as a n factorial is equal to n into n minus 1 factorial. For example, it can be given for 5. 5 factorial is equal to 5 into 4 factorial, or 5 into 4 into 3 factorial, or it can be given like 5 into 4 into 3 into 2 into 1. That is, we are reaching towards the smaller problem. So same thing can be represented as a recursive trace using fact function. So I have a function fact 5. That means I want to find factorial of 5 using fact function. So fact function make a call to itself by passing a value 4. That means fact of 4. Fact of 4 itself make a call itself to fact 3. Fact 3 make call itself using number 2, and fact 2 call itself using number 1, that is fact 1. So we are keep moving towards the base case. Once the base case is reached, it will return a value, that is fact 1 will return value 1 to fact 2. Fact 2 will return a value 2 into 1 to fact 3. Fact 3 return a value to fact 4 using 3 into 2, that is 6. And then for fact 4 return value to fact 5 using 4 into 6, that is 24. And final answer 5 into 24, that is 120 is the final answer of factorial. So let's write program to find factorial of a given number using recursive function. So here it is, main part of the program. Before void main, this is the line that is function prototyping, that return data type is int, fact is the name of function, and in parameter we are passing int n. In void main, we declare two variables n and app, and these two line printf scanf are used to enter and accept number whose factorial is to find. This is the function call. F is equal to fact of n. N is the number whose factorial is to find, and fact is a recursive function. So we make a call to recursive function. So we'll jump to recursive function. First line of recursive function, that is heading. It is similar to function prototype. Okay. Inside body of fact function, as we know, we have two part, base case. So here there are two base cases or base condition. If n is equal to 0, 0 factorial is 1, so it will return 1 to main. Else, if n is equal to 1, it will return 1. So this is base case or termination condition of factorial function. Else, this is the recursive case where in return we call n into fact of n minus 1. So fact of n minus 1 is will keep on calling itself till base case condition is achieved. Once base case condition is achieved, it will come back to main program and value will be assigned to f, which will get printed by printf statement factorial is equal to %d comma f. So output will be factorial of 5 is equal to 120 will be displayed. Next example of recursion is Fibonacci series. Fibonacci series, it is a series of numbers where next number is found by adding previous to number before it. So recursive definition of Fibonacci is in Fibonacci first number, that is fib of 0 is 0 and fib of 1 is 1. So recursive definition can be given as fib of n is equal to fib of n minus 1 plus fib of n minus 2. So for example, fib of 2 is 0 plus fib of 2 is 0 plus 1, that is 1. Okay. Or one more example, fib of 4 is fib of 3 plus fib of 2. So fib of 3 is 2 and fib of 2 is 1. So it is 3. So we'll see in diagrammatically recursive trace of fib function fib of 4. So it has two parts, fib of 3 and fib of 2. Fib of 3 itself again has two parts, fib of 2 plus fib of 1. Similarly, fib of 2 has fib of 1 and fib of 0. And on the left side, fib of 2 has again fib of 1 and fib of 0. So in recursively, fib of 1 will return 1 and fib of 0 will return 0. So 0 plus 1 will be added. So fib of 2 will have 1. Similarly, fib of 1 will return 1. Both of them get added. So fib of 3 is 2. On the right side, fib of 1 will return 1 and fib of 0 will return 0. So these two get added. So this will 1. So fib of 4 is 2 plus 1. That is final answer is 3. Let's write program to display Fibonacci sequence or Fibonacci series. So here in the program, after hash include, I am declaring function int fibo in parenthesis int n semicolon. In void main, I declare n is equal to 0 m comma I semicolon. Printf state and scanf statement, these two statements are used to accept a number. That means how many numbers in a series you want to display. So scanf percent m, a total number of terms in series. And to display Fibonacci series, I use for loop for I is equal to 1 semicolon I less than m I plus plus, that is this loop get executed again and again. Printf percent d, here it is I am making call to recursive function, that is fib of n and n plus plus, because every time we have to call or display number from 0, that is first number, then 1 second number, then 0 plus 1 is 1, then 1 plus 1 is 2, and 1 plus 2 is 3. This is the series. 2 plus 3 is 5, like that. So PON is the recursive function. So we'll jump to the recursive function. This is heading or function definition, which is same like a function prototype. Within the body of recursive function, we have again two part, base case and a recursive case, if and else. Base case, that is termination condition. So here it is n is equal to 0, equal 0, or this is or n equal to 1. If it is 0, it is 0 term. If it is 1, it is first term. That is first and second term. So it will return n as it is and it will display. When and every time it will increment value of n plus plus. Okay. Suppose we want to find five numbers. First four or five numbers. So initially n is equal to 0. So it will, because n is equal to 0, it will display 0. Then n plus plus, n becomes 1. So it will call a function. Again, base condition is satisfied. It will display 1. Then n plus plus, n becomes 2. It will come here. Condition, base condition is not satisfied, but it return pivot of n minus 1, that is 2 minus 1, that is pivot of 1, which is 1, plus pivot of 2 minus 2, that is 0. Pivot of 0 is pivot of 0 is 0. So 0 plus 1, it will display 1. Like that, it will keep on executing this statement. So output will be, when you display enter terms 5, so it will display 0, 1, 1, 2, 3. Thank you for watching this video.